All right, we are going to start. Um, First thing I want to do is I want to do a couple examples of force problems. The hardest thing about doing the problems that we're working on now is visioning what is happening. It is a total change from types of problems that you have done before. It is not simply, here's an equation, put the numbers in. You have to try to figure out what is physically happening, drawing pictures and things like that. And that's what makes this type of problem more difficult. Fortunately, we're starting with the easier ones and they get harder later on. My suggestion, as always, is to do not put things off. Start them as soon as you can. So you can take 1, 2, 3 problems a day. In this problem, you got an elevator with a mass of 1.1 times 10 to the third kilograms. Accelerates upwards. What is the force acting on the elevator cable? So what we have to do is we have to look, okay, here's our elevator. It's attached by a cable. What forces are acting on that cable? Or, well, let's look at the elevator. What's acting on the elevator? Gravity. Gravity has to be acting on the elevator. Now, if the elevator weren't doing anything else, what other force has to be acting on it? Nope. The cable. The cable has to be pulling up on it, right? If the cable doesn't pull up on it, the elevator falls. Bad elevator. So there has to be an upward force, the tension in the cable. Now, a lot of times in the problems, they talk about tension. Tension is a pulling force using a rope or a cable or a string or something like that. That's what tension is. Now, if that's all that there is, that's an FT, force tension. Now, if that's all that there is, these two forces are equal, right? But what else is the elevator doing? It's accelerating. Now, in order to accelerate, our forces are now unbalanced, correct? We've got another force acting upward that we'll call our accelerating force. All right, that's the force that causes it to accelerate. Now, in this case, what supplies the accelerating force? The cable. So the force in the cable would have to be the tension due to gravity plus the accelerating force. That would be the total force in the cable. First, it has to support the cable, or it has to support the elevator. Second, it has to try to accelerate it. So the overall force is going to be greater than the force of gravity. What if the elevator were accelerating downwards? No, gravity is always the same. There'd be less force as it goes down, right? Because the ultimate example is, what if it was in free fall? How much force would be in that cable? 0. Right? Now, the force of gravity, we know that this force and this one are the same. Those are being balanced off by each other. So we can say that the force in the cable is equal to the tension force, or the force of gravity, which is mass times the acceleration of gravity. Mass times the acceleration of gravity is weight. Plus the mass of the elevator times its accelerating, or acceleration as it goes up? Well, the mass is 1.10 times 10 to the third. I'm just going to factor that out. 9.8 plus 0.45. So the total force in the cable, add those two together and multiply them, that's your total force. Is it greater than the weight? Yes. Because you added some in there. What do you get for an answer? What does your calculator say for an answer? $11,275. Now, how would we correctly state that answer? How many significant digits can I have? I can have 2, right? Why do I only get 2? 0. The 0.45 rules everything, right? That's my 2 significant digits. So my correct answer would be 11,000 newtons. Now realize that when you do the worksheet, if this were a worksheet problem, there's going to be 4 choices. One of them will probably be 11,275. And one of them will be 11,000. Which one's right? 11,000. I know. Next one. Let's do one more. Here we've got a rocket. Rocket sitting in a launching pad. Rocket takes off. There's my rocket. Wow, that doesn't even look like a box. Now, initially, there's 2 parts to the question here. What is the mass of the rocket? Yeah, maybe. Okay. Initially, as it's sitting there, the force of gravity is balanced by the normal force, right? The force of gravity is mass times the acceleration of gravity. Force of gravity is also known as weight. Well, if the weight of the rocket is 2.0 times 10 to the 7th, that would be equal to the mass of the rocket times 9.8. So the mass of my rocket would be 2.0 times 10 to the 7th divided by 9.8. Again, calculator gives me what? What does it give you? $2 million. Kilograms. Okay, we can't have that. How many significant digits do we get? 2. So all of these digits over here are insignificant. We're going to have to write it 2.0 times 10 to the 6 kilograms. Why do I have to write it in scientific notation? One, it's big. And if I take my first two, 1, 2 significance, the 4 rounds that 0 to 0, I end up with 2 million like that. Does that show me 2 significant digits? No. I have to write it 2.0 in order to keep my significant digits in line. Next, what's the rocket's acceleration? All right, again, it's kind of like the elevator problem. I want to figure out what its acceleration is in this case. The total force acting on the rocket. The engines are lifting the rocket, right? In order to lift the rocket, what's the minimum force it has to exert? It has to overcome gravity first. Once you overcome gravity, then you can accelerate it. If you're lifting weights, and let's say you got 135 pounds and you're going to lift it, can you lift 135 pounds by exerting 135 pounds on it? No. Will it move? No, because you'll just balance gravity. You have to exert 135.1 pounds of force. And then you can accelerate it. That really accelerates it slow, just so you know. It would take you about an hour to lift it. It would be really hard that way. But you have to exert more force. You have to overcome it. So we got the force of gravity plus the force to accelerate it. Using those subscripts is very common in order to, we've got so many different forces that we have to talk about. We connotate them by using different subscripts. The total force is 2.5 times 10 to the 7th. The gravitational force is its weight, 2.0 times 10 to the 7th, plus its mass of, we just figured out, 2 times 10 to the 6 times the acceleration of the rocket. So now we just have to solve that. 2.5 times 10 to the 7th minus 2.0 times 10 to the 7th is 5 times 10 to the 6th divided by 2 times 10 to the 6th will be an acceleration of, you don't need a calculator, do you? Y is a force to accelerate it. 2 times 10 to the 6th, its mass, times its acceleration. I know. Yeah, a lot of people. See what I actually write instead of print. What? Newtons is a unit of weight, force. Mass is the amount of matter times gravity makes it force. .5 meters per second squared. Two point five times 10 to the 7th minus 2.0 times 10 to the 7th. Then you divide it by that. It's algebra. You gotta subtract and then you gotta divide. Because this is multiplication, you undo a multiplication by division. It's mass times acceleration. All right.